Metabolism and energy experiment. In this experiment chapter, you measure serum glucose and serum ketone bodies along with their levels found in urine. These two parameters could potentially refer to metabolic state of individuals. Determination of blood glucose could be done by single determination from the fasting blood, so-called fasting blood glucose, or FBG, and oral glucose tolerance test, or OGTT. We shall start with the determination of fasting blood glucose. To determine fasting blood glucose, you receive 3 test tubes containing 0.5 ml of unknown fasting blood plasma, standard glucose, and distilled water. Add 0.5 ml of 3,5-dinitosalicylic acid, or VNS, into all test tubes. Mix well on palm. Boil all tubes for 5 minutes. After that, cool the solution down through the running tap water. Add 4 ml of distilled water into all test tubes and mix well. Pour a certain amount of the solution in each test tube into cuvettes. Measure the absorbance of all cuvettes at 540 nanometers using the distilled water sample tubes for setting 0. Record the absorbance and calculate glucose concentration in unknown fasting plasma, referring to 100 mg% standard glucose absorbance. Take a note for the calculated result. Oral glucose tolerance test, or OGTT. To perform OGTT, you receive 8 test tubes containing 0.5 ml of unknown plasma collected at 0, 30, 60, 90, 120, 150 minutes after oral administration of glucose, standard glucose, and distilled water. Add 0.5 ml of 3,5-dinitosalicylic acid, or DNS, into all test tubes. Mix well on palm. Boil all tubes for 5 minutes. After that, cool the solution down through the running tap water. Add 4 ml of distilled water in all test tubes and mix well. Pour a certain amount of the solution in each test tube into cuvettes. Measure the absorbance of all cuvettes at 540 nanometers using the distilled water sample tube for setting 0. Record the absorbance and calculate glucose concentration in unknown plasma collected from different time points, referring to 100 mg% standard glucose absorbance. Take a note for the calculated results. Plot the graph between time, as in x-axis, and glucose concentration, as in y-axis. You will finally get the graphs indicating glucose tolerance curve. Determination of ketone bodies in blood. In order to plot ketone bodies determination, Nitroprusside method is implemented. You receive 3 test tubes containing 5 ml of unknown plasma, standard ketone bodies, and distilled water. Add 200 microliters of 5% nitroprusside solution into all test tubes. Then add 2 ml of 25% ammonium hydroxide solution into all test tubes in the fume hood. Next, add another 2 ml of 10% acetic acid solution in all tubes. Mix well with a vortex mixer. Pour a certain amount of the solution in each test tube into cuvettes. Measure the absorbance of all cuvettes at 540 nanometers using the distilled water sample tubes for setting 0. Record the absorbance and calculate ketone bodies concentration in the unknown plasma, referring to 300 mg% standard ketone body absorbance. Take a note for the calculated result. Glucose and ketone bodies determination in urine. To simplify the determination of glucose and ketone body levels in urine, commercial urine strip is used. You receive a test tube containing unknown urine collected from the same individual from the test aforementioned. A ready-to-use urine strip, a reference range of the strip's results, forceps, and tissue paper. Dip the strip into the unknown urine with the forceps. Try to tilt the tube to inundate all working area of the strip and try to gently remove excessive urine as much as you can. Place the strip on the tissue paper for 45 seconds, allowing the reaction to complete. Compare the results in glucose and ketone body area with the reference range. Interpret the results from the reference range and record it. After level of blood glucose, blood ketone bodies, urine glucose, and urine ketone bodies are reviewed. Compare those levels with the standard range. Identify each value, whether it is higher than, lower than, or in the normal range. Finally, hypothesize whether all the results are the likelihood of which of the cases reported in your laboratory manual. That's all.